works. Okay, hi, welcome again. Let's go ahead and do today absolute values. With inequalities. Oops, that's an S. Okay, so let's look at a question just in the absolute value sign with the equal sign. If I give you guys x plus 3 is equal to 5, what two answers after I take the absolute value would give me 5? So an easy one is, maybe you would think it's going to be 2. 2 plus 3, that's 5, right? And absolute value 5 gives me the 5 I wanted. The harder one is to think of the problem -8. Because -8 plus 3 is -5, and the absolute value of -5 gives you 5. And instead of trying to juggle these possibilities in our brain, what we do is we have a way of solving absolute values. As you split into two versions. Okay, split into two different versions. We say x. Okay, so we had broken up into two versions. One is the positive 5, and the other one is x plus 3 equals to -5. Right? So we then solve these like two separate, simpler problems. -3, -3, -3, -3. And we have x equals to 2, and x equals to -5 minus 3. You owe me 5, you owe me 3, you owe me 8. Hey, these are the same exact answers we had when we just guessed the answer. Okay, so this is, instead of trying to guess the answers, we have a process, an orderly process, and I find that's always a lot easier than trying to guess and check. Sure, if you have a bigger understanding of it, you can come up with these answers pretty quickly. But as the problems get more difficult, we have to have a set of rules, a way of solving them that works all the time, not just sometimes. Okay, so we're gonna do the same exact problem now, except I'm gonna change the equal sign to an inequality. So absolute value of x, so here's my new example, x plus 3. And we're gonna say less than or equal to 5. Okay. So here is the gimme here. We split it like we said before. It'll be x plus 3 less than equal to 5. So what you want to realize is nothing changes. Nothing changes for plus. Nothing changes for the plus side, meaning the 5 and the 5. But what's going to happen is on the negative side, x plus 3, and we were going to write a -5 here, you flip the inequality and becomes a greater than or equal to. If it's equal, it stays equal. But what happens is we have to flip over that inequality sign. And that's the main rule. That's the only rule that's different. Let's go ahead and simplify the problem. I'll keep going. I was going to -3 to both sides. X is less than or equal to 2. X is greater than or equal to -8. So these answers here are very similar to what we had before. But please be very careful here. The big difference is that inequality changed. So now the last part, we want to just graph out there our inequalities. We graph it out by just putting a mark on 2 and -8. Here's 2, here's -8. This is a greater than or equal to, so we're allowed to use a solid bubble. Over here for 2, we put a solid bubble also. Now, here's where we have to make sure we're kind of cool with this. X is less than 2. So here's 2. Less than 2 means we're going to the left, right? Over here, x is greater than negative 8. Negative 8, that means we're going to the right. So we have overlap. So this is an AND problem. Now we can again combine these two to make one big inequality. Isn't x smaller than 2, but greater than negative 8? So we can rewrite this as an AND problem. So there are a couple steps here, but the main takeaway here is that this flip is the biggest mistake that kids make. On a standardized test, they will rewrite this as one big inequality, this compound inequality. This is called a compound inequality. Okay, let's do that again. So our problem starts off with, let's say x minus 2, it's less than 10. Okay, and you could probably guess the numbers, right? Blank minus 2 is 10. 12 minus 2, right? That is going to give us 10. And we can go the other way. Negative 8 minus 2 is negative 10. That would give us the absolute value to a positive 10. But then you want to make sure you don't mess up on the negative sign. So, sorry, the inequality sign. So instead of trying to do that all in my brain, let's just write it out. X minus 2 is less than 10. And on the right side, x minus 2, make sure you don't mess up here. Here's where everyone messes up. We write a flip version of that. Now it's greater than 10. Biggest mistake in the world. You want to make sure you flip that. Oops, I forgot to write the negative. Negative 10. So it's almost like whenever you multiply or divide by a negative, that's when we flip that inequality. If I write negative 2x equals, greater than or equals to 5, when you divide by negative 2 to both sides, x is less than or equal to negative 5 over 2. Remember, we do a flip whenever we divide or cross by a negative. This is the same idea here. Because I stuck a negative, I multiplied it by a negative, we had to flip that inequality. Add 2 to both sides. X is less than 12. X is greater than negative 8. So again, the big takeaway is this inequality here. If you guys worked on the absolute value signs before, it wasn't that hard. You just had to remember to put a negative here on one of the two versions. Our inequalities make us have to add another aspect to that by flipping that inequality. Okay, let's draw a number line here. Two numbers that I see are going to be negative 8 and 12. Would these be solid or hollow? So solid or hollow? Solid or hollow? These would be hollow. Now, do each problem separately. For x is 12 here, less than 12. So here's 12. I'm going to be less than it. Going to the left. X is greater than negative 8. That's going to be to the right of it. They're going to overlap, aren't they? So x has to be between negative 8 and 12. And I find writing this simple number line does help you put the order of our compound inequality a lot easier. Okay, what if it's not an AND problem? So this is like an AND, right? X has to be greater than negative 8 and less than 12. Okay, let's do another one. Same idea. Let's do 3. X plus 1 is, let's do greater than or equal to 12. So to practice our solving absolute values, first thing, we want to get rid of that 3. Before I split the absolute value, let's get rid of what I can. In this case, I can get rid of that 3. Opposite of multiply is divide. So I'm going to divide both sides by 3. rewrite it. Absolute value of x plus 1 is greater than equal to 12 divided by 3 is 4. So we use the division property there. Okay, so we're gonna split our absolute value sign. So again, remember the rule is you can't split the absolute value when there's a bunch of stuff on the outside. So clean it up first, move it to the other side, and now we have a pure absolute value. See, pure absolute value on one side. Then we can split it. If you split it any earlier, you are probably gonna get a wrong answer. One of your two answers will be wrong. So we always keep the positive version, and we're going to flip the negative. So please notice a couple things I did here. I flipped the inequality and I gave it a negative sign. Okay, that's the only thing you have to memorize. That's it. Then we solve the problem like we've been doing the last 3 weeks. Opposite operation of +1 is -1. And the cool thing is it's the same thing to both of these equations. It's like two different alternate universes, but the same thing's happening to both of them. Okay. So if I want to test this fact, let me go ahead and delete this real quick so you guys can see this. Would this be a true number? If I put 3 plus 1 is 4, 4 times 3 is 12. We're looking good there. If I put -5 plus 1 is -4, absolute value of -4 makes it a positive. Positive 4 times 3 is our 12. Yeah. But let's draw our number line and we'll see something a little different here about this problem. So let's first draw the numbers -5 and 3. Would they be solid or hollow? Like remind yourself that. Would that be solid or hollow? I'm thinking it's going to be solid because of the equal sign. They're both solid here. Now let's go ahead and follow the inequality. X is greater than 3. That's going to the right. X is less than -5. That's going to the left. So this is a OR statement. So OR statements are two equations are separate of each other. And what happens is if I pick a number either less than -5 or greater than 3, this will give us a true statement, but nothing in between. In the real world, it's like call me before -5 and call me after 3, because between 5 and 3, I'm busy. Don't bother me. Okay. So you draw the arrows going away from each other. Okay. So in IXL today, you guys will be practicing both these tasks. You guys will be working on and problems and or problems. You'll have to solve them by hand, and then the other Excel you will have to solve them and graph them. Okay. Let's do one more problem as just a practice. Make this one a little longer. So this one will have a couple more of the gotcha type of problems. So if I write -2, absolute value of x plus 4 minus 5 is equal to, let's do 17. Oh, greater than or equal to inequality. So before I can get at the absolute value sign, I need to get rid of the numbers -5 and -2. So which one's farthest away from the absolute value? Remember, we're trying to get the absolute value alone. Would that be -5 or -2? -5 is farther. So opposite of -5 is +5 to both sides. -2, absolute value of x plus 4 is greater than or equal to 22. Next move, if I divide by a -2, this is one of our rules, our special rules. If I divide by a -2, I need to remember to flip that inequality. X plus 4 is now less than or equal to 22 divided by 2 is 11. So please be aware what happened here. A flip happened because we divided a negative over. Now we have the absolute value alone by itself. Now we can do a split. X plus 4 on one side is less than or equal to negative 11. Oh wait, here's a problem. I just noticed this. When I wrote this negative 11 here, can this ever be less than a negative? Can absolute value ever be negative? So there's actually no solution here. Okay, so be ready to say that. Absolute values can never be negative because absolute values make numbers positive, and that's something that we have to catch. You could try to keep solving this, but it wouldn't work. Turns out none of these answers would have worked. Let's go back and quickly look at why. Whatever answer you came up here, weren't you going to make it negative? And what's a negative and a negative is not even more negative? Can these negative numbers be greater than a positive 17? Never going to happen. Never going to happen. Okay. Okay, so be careful about that. Little trick question there. But what if, let's test something out. So let's try this other example really quick. Similar to what we did before, but I'm going to ask you this question. What if I write x plus 4, absolute of x plus 4 is greater than negative 2? Is this ever true or always true? Remember, absolute values are always positive, right? And aren't positive numbers always greater than negative numbers? So it turns out this is always true. So all real solutions. So whenever you have an absolute value that's greater than a negative, right, that's already weird because absolute values are not supposed to be negative, right? But since it's an inequality, this is a true statement. Aren't all positive numbers bigger than negative numbers? They are. So this makes every value you plug in here. If I plug in 1, if I plug in 5, if I plug in 10, if I plug in negative 100, the absolute value will force it to be positive, and it will still be greater than negative. So be careful of these two trick answers here. Can a positive answer be less than a negative? That can never be true. Can a positive answer be bigger than a negative? That is always true. Okay? Let me say this again. Our problem happens when an absolute value happens with a negative number, right? We said that our absolute value cannot be negative. Never true, right? It can't be negative. But with inequalities, if I do the same idea, can a absolute value be greater than a negative number? Can an absolute value be less than a negative number? Okay. So let's ask this first question. Can an absolute value be greater than a negative number? Isn't this always positive? So without doing any more work, hey, this is always true. Positive numbers are always bigger than negative. So this is all real numbers. So whenever you end up with this scenario, you can just stop here and say, you know what? This is true for all real numbers. But on the right here, is it true that positive numbers are less than negative numbers? This is never true. So no solution. Okay.